Today I will give an introduction to object detection with Vertex AI and ML kit. So in the next 20 minutes, I will show you what is Vertex AI. I will present some features of the ML kit vision API. We also used this kind of technology in a hackathon project a few weeks ago, building a smart shopping cart app. So I will give a short demo of our app, what we achieved in a few days, and our learnings during the project. So what is Vertex AI? It's a platform from Google. It's integrated into the Google Cloud Service, so you can use it for machine learning. You can train and deploy your own machine learning models. There's a free trial, so you can play around with it. But if you're using it for more features, you have to pay. There's also an ML Vision API SDK for Android. So it has a lot of features, so we only focus on image labeling. Image labeling is used to analyze pictures or video streams, so we can identify, for example, people, things, places, activities, and so on. So there's a already ready-to-use machine learning model that is able to detect about 400 different entities, but it's also possible to create your own model, so you can detect more stuff you like. It depends on your use case, what you need. There's also another API, it's called object detection, and this one is used to detect certain objects inside an image or video frame. You will get the boundaries, so like the position in the screen, and you will also able to track different objects from screen to screen. So you can follow objects from frame to frame if this some kind of object is moving through the picture or through the video. It's running on the device, but you could also use it on your backend. I will come later to this. There's also ready pre-built models, but you can also use your own model, train your own model, and put it into the app. And there's also object sharing, so you can follow directions. So if you want to use a model, you can go to the TensorFlow.org hub page and see if there's already a pre-trained model for your use case. It's not only image and object detection, so there's, for example, a bird where you can use it for language processing. So if you have text, you want to write some kind of chatbot like ChatGPT, you can use this model to write a chatbot. There are pre-trained models for object detection you can use. Maybe it fits your use case. The correct objects you want to detect are already inside the model. Or there are also models for generating new images. So you can apply a certain style to photos. And of course, there's a food classifier. For example, if you want to check out if there's some kind of cake or banana inside the photo. So we can use some pre-trained models for this use case. Our hackathon project idea was to build a smart shopping cart. So I'm working on Scan and Go, and the customer has to scan barcodes on the products and put them in the basket. But we try to avoid scanning the barcodes, so the user doesn't need to scan it, just drop it into the shopping cart. The camera will detect which product was added to the cart. You can add it to existing shopping carts, so it's like a retrofit solution. And we tried it with object detection. We trained our own model because there was no pre-trained model for our use case. And we integrated into the existing Scan and Go solution. So we had 2.5 days at this hackathon project. And first step was get a shopping cart. One of the benefits is working for Rewe, you don't have to steal one, so you get a free one. We also had help from Zebra. They borrowed us a tablet. And as you can see by the duct tape, we are good at software, but not so good at hardware. So, but it worked out. So the tablet was positioned to film into the cart, so you can see everything that was put inside. And start slow, low barriers. We choose 3 different products. So tomato sauce, pesto, and spaghettis. And the first step was taking pictures, many, many pictures of each product. So we started with 10 pictures for each product, but soon realized that's not enough, so we took about 100 pictures of each product to train our model. After taking the pictures, you also have to label them, so the training algorithm knows what is inside the picture. You have to put a label on each photo, and after you labeled all your pictures, you have to upload them to Vertex AI via the web interface to begin the training. So your data source could be different things. So maybe you have a cloud storage already or a BigQuery database, but we use the file data storage to upload our photos to Google. And there are also different container images that you could use. So PyTorch, Scikit-learn, XGBoost, but we decided to use TensorFlow because we wanted a model that is working on the device, not inside a backend. And yeah, you could also choose between different compute engines and optimize your model for different hardware. So we uploaded the photos. So the first spinner where you can set your data set, you choose the folder where all your product images are lying. And yeah, you have some kind of options to choose. So we use AutoML for our model. And at the bottom, you can see we use the Edge model. So later, the model file could be used on the device. So it's important to choose the right model for your use case. In the next step, you have to set the model details. So you can choose to train a new model, or if you already have a new model, a model from a previous test run, you can improve it. And yeah, you can split your images. So these are the defaults. So 80% of your pictures will be used for training the model. 10% of the pictures are used for validating your model and for testing. So you can play around with the numbers, see what's improving your model. And after this, in the next step, you can also set the training options. So there's an offset between accuracy and fast prediction. So if you want a higher accuracy, it gets slower. But if you want faster predictions, the accuracy will get less good. So it's also an option you can play around and to improve your model. Yeah, last step, training the model. You are telling the cloud how many hours the model training will take. So it's not free. So we had a free trial to play around with the Vertex AI, but you can set a limit. It's too much hours, we will get a high bill, but yeah, not my money, the company was paying, and we had a free trial. So next step, you start training, and yeah, you have to wait. So it really takes a very long time to train the model. We only had 2.5 days for our hack project, so we are kind of in a hurry to get it ready for our presentation, and yeah, we waited, and our first test run finished about 1 hour and 40 minutes. It's quite long, so you can't develop anymore. You have to wait until the file is ready, and yeah, if you will take more pictures, it will get longer and longer, so you have to choose wisely how many hours you will spend on training the model. So now the model file is trained, and you can deploy it and test it on your device. So you have, again, different options. You can put it in a Docker container to deploy it on your backend, or you can use TensorFlow.js for your web application. But in this case, we don't need these kind of two options. We choose TensorFlow Lite because we wanted a model that is used inside the Android app on the device. So you download the model file, put it inside the Android app, the normal Android asset app folder. As you can see, we used 4 different models, played around which one was better, and copied the TensorFlow Lite file into the app. TensorFlow Lite has the advantage that it's had a smaller footprint, so the model file is a little bit smaller than the normal TensorFlow models, and that's what you want for your app, because the app file size will also increase. And also the other advantage is if the model file is inside the app, you don't need some kind of backend or network request, so everything is working offline. There's another option to put your model file into the app. There's an option to host your model file on Firebase. So you put the file on a Firebase cloud, and inside the app you can use a remote model. So you're setting the name of the model here in the builder, and if your app and your user is on Wi-Fi and has a good data connection, you can upload the model file inside your app. So you don't have to redeploy the app to the Play Store, for example. You can use the existing app and update your model from time to time, improve it, without the need that the user has to update the app. Yeah, what do you get time to try it out? So we only had 2.5 days, but it's an option. Maybe it fits your use case. So now we have the asset file inside the Android app. And yeah, this is just a slide of code. We show you how to integrate it. Which file you want to use. And yeah, you have also some options to customize the object detector. So there's a stream mode. Stream mode is useful when you're using video, so not single images, but a video feed where you have to detect objects in a live video stream. You have to enable the classification because we want to get the names of the objects. So if it's tomato sauce, pesto, or spaghetti in our case. And you can set a classification confidence threshold. So how sure is the model that this object is, for example, tomato sauce? So in this case, it's 70%, and all results below it will get filtered out. And you can also play around with the amount of objects in the picture that could be detected at the same time. So we set it to 3 to only detect 3 images at the same time. And you also have to enable multiple objects to get not only the most prominent object in the current view, but also all objects in the picture. So now the object detector is configured. And you want to show your user some kind of preview. So there's the Android X camera preview. Currently, this view is still not available in Compose, so you have to wrap it around in an Android view. But maybe Google will deliver that at some time. So you have to still use the old Android view system for this. And yeah, this view is showing a live preview of your camera. So the user can point the app at the correct objects. So now we have our preview view, and we, last but not least, we need our MLKit analyzer. So you connect the preview view to the image analyzer. There's some kind of mathematics because the camera picture has a certain resolution, and also your smartphone screen has a resolution, and these mostly don't match, so you have to translate the different coordinate systems. But the MLKit analyzer is able to do this for you. So also keep in mind the rotation of the camera, the degrees, if it's the picture is shifted. Yeah, you have this kind of callback, so you get an array of detected objects, and yeah, you can use it to show it to the user in the app. So in this case, we filtered all objects with a lower confidence than 80% because we only want certain matches. And the text, like the labels, we also we set to the pictures will be available here. So we are returning a list of strings of all objects detected in the picture. So how does the object detection class look? So you're getting a tracking ID. So if you, for example, you have an object that is moving in a live video stream and you want to compare it from frame to frame, there's a tracking ID for your object, so where you can re-recognize where it moved. So if you have different objects moving to the picture, you can identify them by the tracking ID. So you also get the bounce, so the position inside the camera screen, so it's possible to draw some kind of rectangle around it. So you have to put a surface layer above your camera preview, and it's quite nice for debugging because you can see in the live camera preview which objects are detected and at which position, and also the labels. You also get the categories, so these are the labels you were setting to your image set when training the model, and you always get a classification confidence, so how sure was the model that this object is, for example, pesto. Yeah, we tried it. We trained our model the first time, and we are trying around and pointed at different objects, and everything was tomato sauce. And we wondered, okay, we trained a model that only knows 3 different kinds of objects in the world: tomato sauce, pesto, and spaghetti. It doesn't know anything else, so it has to match one category. And most of the time it was tomato sauce. So this was our first learning. You can't take only picture of objects you want to detect. You also need pictures in your training set that are not the objects you want to detect. So some kind of fallback, for example, an empty card or other objects like the Coke bottle or anything else. So you have to put them also into the training set to make the model more robust to other objects. Yeah, now a live demo. I hope the video is playing. This is the app we built in 2.5 weeks. So the customer goes to the store, takes the tablet, puts it on the shopping basket, and puts stuff into the basket, and we call it drop and go. So just throw it into your shopping cart, and the app will detect it and put it into the digital cart. So I hope the video is playing. So you start your shopping session. The first product is added, and on the left you can see pesto was detected. It was added to the cart, spaghetti, and tomato sauce. So all products we trained our model got detected, and yeah, it was quite nice to see it in action. So yeah, our learnings. Training custom models can be very hard, time-consuming. I showed you it took about 1 to 2 hours to train a model with only 3 different products. Imagine a larger base of data sets where you have about 100 products with thousands of photos. It will take time to generate the model file. So you have to take that into account. You have to wait, test your model, train your model again, improve it. And you also need many photos. So we started with 10 photos of each product. That was not enough. At the end, I took about 100 photos of tomato sauce. If someone is seeing my smartphone gallery and asking, why has this guy 600 photos of tomato sauce on his phone? Yeah, I should show him this talk. Yeah, and object detection only works well for a small amount of objects. So we had a small shopping basket with 3 products, but if you have about 10 or 20 objects, it's the same objects will get hidden by other objects, so it's very hard to detect everything. And also, we tested in different lighting conditions. So inside the office, we had good lighting conditions, but if it gets darker or lighter or bright sunlight, the results will also vary. So you have to keep that in mind, that your model is trained under different lighting conditions or different backgrounds. So more pictures in this case too. So you have to take pictures with different backgrounds. Yeah, thanks to my team. Here's a picture of our team during the hackathon. One of us is also here. You can ask your questions too. Yeah, it was very fun to build this product. And yeah, maybe in about 10 to 15 years, not sure, or maybe never, we will see. Yeah, we could use it in the store. Yeah, thanks. That's my last slide. So here's a small advertisement, so some invitation for our party. There's a Berlin Droid launch this evening at 20 p.m. And yeah, you can join at Seabase. A very cool company sponsoring the drinks. Surprise. So come by, have a drink. I will be around. You can ask questions. Thank you.